Okay, so for 10-1, the Pythagorean Theorem and its converse, we first may have already learned about the Pythagorean Theorem as a squared plus b squared equals c squared. Now the most important part of the Pythagorean Theorem is that c is the hypotenuse, okay? So a and b, it really doesn't matter which one's which, but those are our legs that are squared, and then the hypotenuse squared has to be c. That is the most important part. It's always the longest side, and it's always across from the right angle. Okay, so that's a key part there. Now, while you may know how to use the Pythagorean theorem, Pythagorean triples are very handy to memorize. So it's whole numbers that make right triangles. The most common one used is a 3, 4, 5 triangle. And there can be multiples of this. So if we took all of these and multiplied them by 2, we could have a 6, 8, 10 triangle. That's just a Pythagorean triple, a multiple of 3, 4, 5. There's also 5, 12, 13. Memorizing Pythagorean triples and knowing that whenever we see a right triangle, and if one of the legs is 3 and the hypotenuse is 5, we know that this must be a 3, 4, 5 triangle. If it's a right triangle. It has to be a right triangle for that to work. So, there's also a way to identify types of triangles. So, if a squared plus b squared equals c squared, then it's a right triangle. We know that from the Pythagorean theorem. But if c squared is bigger than a squared plus b squared, then the triangle is obtuse. If c squared is smaller than a squared plus b squared, then the triangle is acute. So there'll be problems that are just asking you, is this triangle obtuse, right, or acute? And so that is very handy. Now, something that got mentioned in 9-4, but that we pushed off to learn until 10-1 was simplest radical form, okay? And what this is, and you may recall it from other classes, but during chapter 10, there will be no decimal answers, okay? So in chapter 9, I accepted decimal answers, but in chapter 10, we are not. So something to keep in mind is, I'm just going to use this example. I have 8x and 20. Okay, so when doing the Pythagorean theorem, where we do a squared, remember c has to be the longest side across from the right angle. So I can do 8 squared plus x squared. Now it doesn't matter if I switch those two, as long as c is the 20 squared. Okay, so then I take that, I do 8 squared is 64 plus x squared plus 20 squared, which I believe is 400, but let me double check that. 20 times 20, yes, it's 400. And then I subtract 64. So now I have x squared equals 336. Okay? Now remember, to get rid of x squared, we square root. So we square root both sides. Now here's the difference. We can't just type this in our calculator anymore. I will not accept decimal answers. So here's what we do. First, we break down the number under the square root to its factors. So what that means is we can take 336, and hey, I know 2 goes into 336, at least, because it's an even number, right? Divided by 2, so it's 168 and 2. Well, I know 2 must go into that too, so I'm going to divide by 2 again. 84, look, that one's divisible by 2 as well. 42 and 2, and if you realize that 4 could have gone into this, that would have been totally fine too. 42, I know that 21 and 2, and then 21 breaks down, sorry, I ran out of space, to 3 and 7, right? Okay, so pairs come out of the square root as one number, and singles stay in the square root. So here's how we do this. We got 2 2's at the bottom here, and I'm not worried about the numbers that broke down further. But I have 2 2's right here, and I have 2 2's right here. So I pair them up, and let me rewrite this up here. 336, 168 and 2, 84 and 2, 42 and 2, 21 and 2, 3 and 7. Okay, so pairs, I'm going to double them up. That's two 2's, that's two 2's, and these are singles, right? So what I'm going to do is I'm going to take the pairs out as one number. So 2 comes out on the outside, another 2 comes out on the outside, and then inside the square root are the singles. Singles stay in the square root, okay? So my 3 comes in and my 7 comes in. So then I multiply. 2 times 2 is 4. 3 times 7 is 21. So I have 4 square root 21 is my answer to that. So I would say x equals, that's my answer. Okay? I do not just put this in the calculator. I have to do it in simplest radical form. I have a whole poster about it that you can look at on the poster page on Canvas. Highly recommend looking at that. Or if you want to just Google simplest radical form, if this doesn't make enough sense for you, that right here we got a pair of 2 comes out, a pair of 5 come out, a 3 and a 5 stay in, we multiply, and that's simplest radical form. Let's look at some examples in the textbook. First of all, when solving a missing side of a right triangle, we can use a squared plus b squared equals c squared. That's totally an option where we square them, add them together, square root, because c is our missing side. Remember, if c wasn't our missing side, we'd have to put a number in for c and solve for a or b, okay? And this one was a whole number, okay? Which actually means it's a Pythagorean triple. Now, if you think about the Pythagorean triple, now this isn't required, but if you memorized the 3, 4, 5 triangles, and you realize that 18 is just 6 times 3, and 24 is just 6 times 4, well then, the hypotenuse must just be 6 times 5. So it's just a 3, 4, 5 triangle that's multiplied by 6. So knowing this shortcut is very handy and can save you a lot of time if you recognize at minimum 3, 4, 5 triangles, and possibly even more. There's a whole list of Pythagorean triples at the bottom of this page. Right here we got 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25. Highly recommend memorizing the 3, 4, 5 triangle. Okay? This is the example I just did in on the scratch piece paper right here, but it didn't show you the fullness of how to break down the square root. They do it as factor out a perfect square. I like breaking it down entirely. That way I can make sure I'm not missing any parts. But that's exactly what we just did. And remember, when we know the hypotenuse, that has to be our c. Let's turn the page and look at it once again. This problem actually asks us to not leave it in simplest radical form. It asks for the actual length. So that means we type it in the calculator. We only type it in the calculator when the problem specifically asks for it. Okay? And then we can see if something is a right triangle or not by simply saying, well, if a squared plus b squared equals c squared, then it's a right triangle. Remember, c isn't going to be the last one. It's going to be whichever one is the longest. So 85 would have to be my c here. And because they equal, it is a right triangle. And the last one, to figure out if something's a right triangle, or what kind of triangle it is, if it's obtuse, acute, or right. Remember, we have this little chart right here. If it's equal, it's a right triangle. If c squared is bigger, it's obtuse. If c squared is smaller, it's acute. So we square it. 196 is bigger than 157, so c squared is bigger, so it's obtuse. Okay? There are 5 options today. You have textbook problems, Math Excel, online quiz, create your own. But I also have an option E today, which is a worksheet. It's a really great worksheet to help you understand the Pythagorean theorem better as well. All the problems are pretty much the same on all the options. But that is what 10-1 Pythagorean theorem is all about.